Hi, welcome to the third DSI seminar. My name's Jaz Sikhan. I'm in the Political Science Department and Statistics. Today we're very happy to have Jure Leskovec from the Stanford Department of Computer Science be our speaker. He comes to Stanford from Carnegie Mellon, where he did his PhD. After which he was a postdoc at Cornell at John Kleinberg's group along with other people. Currently at Stanford, he's in the Info Lab and in the AI Lab. And before CMU, he's from Slovenia. And today he's going to talk about how people evaluate each other in social media, and a lot of his work is on social networks on the net. Thanks.
Okay, good. Great. So thank you for the invitation. Thank you for coming. I'm very happy to be here. So I'm a computer scientist, as was said, but for today I chose a topic that's very non-technical. So all we will be doing is counting. As non-technical as it can get. Okay, so the topic of today will be how people evaluate each other. But since I said I'm a computer scientist, I'll start from the computer science angle, right? And what has been happening in the last few years is that we've been witnessing this what I will call a social transformation of computing, which means that technological networks today are intertwined with social networks. And this had lots of transformations for computer science as a discipline. And the important things that this change was the first sort of how we as society, how do we produce information and how do we share it, also how people interact and communicate with each other, and also it broadened the scope and changed the scope of the computer science as a discipline at large, right? And then if you ask, okay, what kind of new issues did this open in computer science, there are sort of two things to think about. So first one is to ask, how do we design and how do we build things in this new space, right? How do we combine ideas and models from other disciplines with the ones coming from computing in terms of understanding social networks and other types of complex networks, understanding designing with incentives and using tools coming from game theory, all the way to thinking about social media, reputation, recommendation, and contagion in this kind of social as well as technological networks, right? So that's one sort of side of the coin in terms of why is this exciting for computer science. There's another side of coin which has sort of the broader implication. And the broader implication, I think, comes from the fact that the science advances when invisible becomes visible. And if we think about this, really what we have today that we didn't have a few years ago is that we have this, you can think of it as a telescope or a microscope or a sensor into human lives, right? And this sensor into human lives is really the web, and everything that we do today leaves some kind of digital traces online that then we can collect, we can study, and we can try to understand what are the fundamentals of human behavior. And of course, this also allows us to go then back and try to address, let's say, some of the long-standing social science questions, because the resolution at which we can now analyze and look at humans all of a sudden became much higher. So really, what I will talk about today in my talk is one such example where sort of invisible is becoming visible and where we can do something both in terms of computer science, but also try to distill out some fundamentals of human behavior and how we operate as humans, right? And really, what I will talk about today are human evaluations, right? And if you think about this in the online setting, then we have many cases, right? And here are a few examples where people express their attitudes and opinions online. So we do this through what I will call consumption, where basically we are buying things, we are clicking things. We are doing this through actions in a sense that we are explicitly rating products, explicitly liking various items on the web. And also we are doing this through text, right? By writing comments under the news stories, by writing product reviews and things like that, right? So this is what we are doing online. And at least, right, for a big chunk of online applications, they critically depend on this ability of people expressing their attitudes and opinions, right? Any kind of recommendation system-based company, right? For music, you have Pandora and Last.fm. For restaurants, we have Yelp. For movies, we have YouTube. For products, we have Amazon, right? All these basically depend on us expressing opinions and, feeding their machine learning recommendations systems with ground truth data, right? Other examples of where this is critical is in terms of, let's say, trying to rank various kinds of items, trying to use wisdom of crowds to discern the truth or lower the noise in the data and so on, right? So this is how opinions get expressed on the web and why they are important. And really, if you think about what do people express opinions about, there are sort of three things to think about, right? So the first one is the most common thing that people do on the web is where we express opinions about items. And what I mean by that is, for example, is when people write reviews about movies, when they write reviews about products, things like that, right? So basically what happens is that there is a set of people, there is this set of items, different types of microwaves, and people say this microwave is good, this microwave is bad, okay? So there are also two other types that are recently becoming, in some sense, more common. And the first one is when people evaluate or express opinions about other people, right? This especially happens in online communities where you have a community of people and these people express, let's say, positive and negative opinions about each other. There are two examples, at least two examples of this. One is actually in terms of Wikipedia, and I will tell you more about this, where basically there is a public promotion process and there is a public election going together with that process. So the idea is that people say, I support this candidate for promotion, I oppose this candidate for promotion. And what this allows you is then to think about this as these evaluations as social networks with positive and negative signs, with positive and negative evaluations. And then the second case that can be thought, again, in terms of people evaluating other people is in a sense where when this evaluation happens indirectly. What I mean by that is that again we have a online community where people create content, but then other people evaluate those pieces of content, right? So in this sense, question answering communities, for example, like Stack Overflow or Yahoo Answers, are example of these things where you have a closed community of people that interact with each other. Some people are producing content, meaning they are producing answers to questions, and then other people are rating those answers as correct or incorrect through giving thumbs up and thumbs down, okay? And the topic of my talk today will be really focusing on these two examples where one member of the community is evaluating another member of the community, either directly or indirectly through the piece of content that other member produced, right? And if you ask, okay, where are these kind of evaluations going on when people evaluate other people online and what is their meaning, you find many different kinds of semantics of these positive and negative evaluations, right? So for example, in online product review websites that we will look at, these evaluations will actually mean I trust you, right? So I trust your product reviews or I distrust your product reviews. In terms of political discussions and so on, you can positive and negative evaluations can mean I agree with your statement or your position or I disagree with your statement. The other thing that I was mentioning in terms of Wikipedia is where these evaluations mean I vote in the favor of you being admitted into the community, of you being promoted to the administrator level, or I vote in the opposition of doing that, right? And for example, on Amazon and elsewhere, people vote and say, I find your answer or I find your opinion helpful or not, right? So in all these cases, people are voting directly or indirectly on the content that other members of the community have produced, right? And if you think about this, what are the analogies to this behavior in real world? Like we as academics, we can find many of them, right? So for example, one such case is where community members evaluate other community members is, when we determine whether our papers should be accepted to conferences and journals, right? In a sense that I submit a paper and then other members of the community evaluate my paper and decide whether that should go in or not, right? The way how we fund grant proposals is in a sense a very similar case where people evaluate the content, the grant proposal of some other member of the community. And also things like who gets hired and who receives awards and so on are in some sense a natural analogy of the process that I'm trying to study through this telescope of the web, if you like. Okay, so when I have these user-to-user or human-to-human evaluations, what are kind of interesting questions or issues that we may want to ask? First question is really, what are the basic mechanisms in which users evaluate each other, right? Sort of what are the factors that play a role when one person decides to either positively or negatively assess the other person? And then the other thing that we will be looking is, how can I now that once I have these evaluations, how can I compose them into some kind of coherent opinion of the whole community. And maybe even more interestingly, can I look at the composition of the community or composition of the people that actually cared enough to express their opinion and try to guess something about what the final outcome or what is the opinion of the whole community. So these would be sort of types of questions that I would like us to think about, right? So let me just define the setting for this talk, right? So the setting is I'm interested in studying how people evaluate each other. I'm interested in doing this to meet the two different levels that will be both equivalent when either one person directly evaluates the other person. This was the case, for example, of this Wikipedia election example, or when people evaluate each other in an indirect way where one member of the community produces a piece of content that is then evaluated by other members of the community, right? Now, if this is the setting, what kind of data will I be using? Here are the data sets that I'll be showing you examples from for the rest of the talk. So the first one comes from the Wikipedia adminship election process, right? So the idea there is that you have the people, the editors who are editing the Wikipedia articles, and then there is also this other class of users who are the Wikipedia administrators. And for some editor to become a Wikipedia administrator, there is a public election and a promotion process, right? So somebody nominates a particular user to become an administrator. There is a public election. Other users come and explicitly vote in favor or in the opposition of that user becoming promoted in an administrator. After about 2 weeks, the elections are closed. You see how people voted, and then the decision is being made, right? So that's the first case. We have around 100,000 votes, for example, in English Wikipedia. I will also show you some results for German, French, and Spanish Wikipedia. This is one case where people really, members of community, evaluate other members of community. The other two cases that I'll be talking about are these indirect evaluations, where people evaluate pieces of content created by other members of the community. So here I'll be talking about the Stack Overflow, which is a very popular question answering website. It is about people having coding and programming questions, and then other people contributing answers and so on. And here and the point for us here is that whenever somebody answers, other members of the community can then up or down vote that particular answer. And we have I think 1 million people, 3 million questions, 7.5 million up votes and down votes, right? And then the last example will be in terms of the opinions product review website. So the idea here is that people review products, but what then other members of the community do, they rate whether this review was good or not, right? So we will be studying what is the quality of reviews contributed by other members of the community, right? So in this case, 5-star rating on the review will mean that this is a positive evaluation of someone's review, and 1 to 4, I will call it as a negative, just to keep things simple, right? So that I can distinguish between positive and negative evaluations. So just one thing to be clear here, this is about I'm rating the review you wrote on a particular product, right? So it's not how you rated the product, but how good was your review. So I'm rating your review in terms of was it comprehensive and so on, and not whether that product that you reviewed was good or not. Okay, so it's about evaluating a piece of content that you or somebody else created. Okay, so what is that I'll try to ask in this talk is, first I'll be talking about what factors or ingredients lead people when they evaluate each other. Then in the next part I will be asking, how do I synthesize or how do I create a composite description that accurately reflects the cumulative opinion of the community. And then the last part will be, how does even just the audience composition in some sense tell me what the audience thinks about a particular piece of content. Okay, so that's basically the plan for my talk. And for the first part, I'm really interested in this kind of setting where there is the user A, I will call the user the evaluator, and there is the target B. And the question is, how do the properties of A and B, or maybe just B, affect A's vote, right? And what are the two important features that will be coming up in the talk? We will see is one is called status and the other one is called similarity, right? So first I want to define them so that we'll all know what we talk about, and then I'll show you how this status and similarity affect A giving a positive or negative vote to this candidate B. Okay, so what do I mean by status? So for me, status is very simple. I will simply define it as a level of contribution, merit, achievement, or reputation in a community, right? So in terms of Wikipedia, this will be just the number of articles you have edited in your life. Or in Stack Overflow, this will be the number of answers you have contributed to the Stack Overflow community, right? So it's just a simple count of actions of a person on the website, okay? And then the similarity, the idea behind that is that it tries to capture the overlapping topical interests of users A and B, right? And basically the idea is, do we tend to answer, do we tend to contribute answers on that are on similar topics, or do we tend to contribute answers in different parts of the community? Or do we tend to edit articles on Wikipedia that are on similar topics or on very different topics, right? And this will be just cosine similarities of TF IDF vectors between the words of articles that you have ever edited. And on Stack Overflow, this will be the questions you contributed, right? So sort of very simple things. Okay, so now that I defined what are the status and similarity, let's go back to our thing that we are thinking about is how evaluator A evaluates target B. And the question is, how do the properties of A and B affect A's vote? And there are two natural and competing hypotheses, right? So the first hypothesis, or one way to think about this, is to say that the probability that B receives a positive vote just primarily depends on the characteristics of B, right? So if you think in terms of, about this in terms of Wikipedia adminship election process, the idea would be, that there is some objective criteria for user B to receive a positive evaluation. Basically, we could say if you've been a member of Wikipedia for about 2 years, you have edited 10,000 articles and created 700 new articles, then you are above the bar to become elected and be promoted at the level of Wikipedia administrator. Yes. Yes, good question. So the question was, do you get to see who else voted? So the Wikipedia promotion process is completely public. So there is, basically the way it works is there is a Wikipedia page, everyone comes and edits that page, and you add your name, timestamp under the, the support column or the oppose column. What we find, however, is that we had this hypothesis that we should think about Wikipedia promotion process as some kind of decision-making, where we go around the table and ask person to person. There is no correlation in the votes. So people basically come and independently cast these votes. So we tested for that. But thanks for the question. It's a good one. Okay, good. So this is the first hypothesis, right? People come and, there is this objective criteria for user B to give a positive evaluation. Another question? Sure. So should I repeat the question? Yeah. So the statement or the question is really that people don't really look at status and similarity in Wikipedia, and that my definitions are far too simplistic. What I will say is, let me show you my results, and once you'll see how things are biased, people think they're doing one thing, but the data shows something very different. Okay, so I'll answer your question later. But it's a good point that I definitely agree that, the way we define these things, like the way I define them is in a very simple way, and of course you could improve on upon those definitions, and we were also very careful trying out, what kind of similarity metrics you use and so on, but the results at the end don't change anything. So I just showed you the most simple version of the definitions. Okay, so the first definition, the first hypothesis, second hypothesis is really that the probability that B will receive a positive evaluation, it depends on the relationship of characteristics between users A and B, right? So really the way to think about this would be that the voter or the evaluator compares him or herself to the candidate B and then makes an evaluation, right? And the question is, which of these two turns out to be supported by the data more, right? So here is the plot that gives you the answer, and it's a bit complicated plot. So let me explain it, right? So what I want to ask is, how does the status of target B affect affects A's evaluation, right? So what I'm doing here is I'm plotting you what is the status of the target, so what is the status of B. Again, status is just the number of articles the guy edited. And then what I'm doing here is I'm keeping the status difference between A and B constant, right? So when the status difference is positive, this means that A has high status and B has low status, right? And when the status difference is negative, then it's the other way around, right? I have a small number minus a big number, right? And what are the observations? So the first observation is that these lines follow the status difference. What I mean by that is the red line means a low status person evaluates a high status person, while the pink line means that a high status person is evaluating a low status person, right? The difference is positive. And what you see is that the probability of giving a plus seems to decrease with the status difference, right? It's basically that it seems that based on this is that people compare their status to the status of the target and then make a decision. And if the target is of higher status, then you are more likely to give a plus. And if the target is of negative status, then you are in some sense more likely to give a minus. The other interesting thing that you can see in this plot is that these lines, modulo the stuff at the beginning, is that these lines are flat. Right? What this really means is that when people compare each other, they compare each other based on the difference. Right? So here I'm increasing the status of B, but the probability of A giving a plus doesn't really depend on, let's say, the ratio of the two statuses. It really depends on the difference, or it just is flat as a function of the target's status, right? Which could sort of mean that you get bothered whether somebody earns $1,000 more than you, regardless of whether you earn $1 million or you earn 1,000, right? It's about the difference that that people care about when they are creating these elections, right? So really what we see is that the flat curves tell me that the probability of a positive evaluation doesn't depend on the status of B, but it just depends on the difference in status between A and B. And then the different levels tell me that for different levels of status difference, they result in different behavior, meaning that the probability of giving a plus, let's say, decays with the status difference, right? So this is the first plot that tells you what's going on, what's the effect of status in terms of the person giving a positive evaluation. The other question is, sure.
Do you know which of those were already admins before they voted or not? So here you're just comparing the status, not only also the admin status. So
that's a good point. So what happens is that in Wikipedia community anyone can come and vote, right? And people that come and vote, sometimes they are existing administrators, sometimes they are just editors. What we find is that on average, administrators tend to be just a bit more negative, but not really. So it's in terms of people that sort of there is definitely a selection effect of who shows up to vote, and I will come to that also. So I will give you an answer to your question in a few slides. Okay. So one more, yeah.
A related question to that. Do you have a fixed effect for the vote for the candidate, or do you control for the time period? Because I have a sense that it's gotten increasingly more difficult to become an admin in Wikipedia. So you'd expect that there's more negative votes and there's more people who are more experienced because they've been editing more over time.
That's a good question, but we haven't seen any significant drifts in terms of getting more difficult. So the Wikipedia election success rate is around 50% throughout the time. But let me go on, and I'll take more questions later. Okay? So that was the effect of status. Now you can ask, what about the effect of similarity, right? And here are two hypotheses. Again, both are natural and both could be true, right? So the first one is to say evaluators are more supportive of the targets in their own area, right? So what this means is the more similar we are, the more I like you, right? So and the other one could be exactly the opposite, right? Saying, the more familiar are the evaluator and the target, then, the better they know each other's weaknesses. So for this reason, the evaluation is harsher and more negative, right? And if you think about, I don't know, when we review papers, many times you can see that you are either in this or that category in a sense that you say, oh, this is from my area, I should be very supportive, or you say, I really understand your paper because we are in the same area, I know the weaknesses, so here we go, right? So the question is, which of these two is happening, let's say, on Wikipedia? And what you find is that there is this positive relation between the similarity and the probability of receiving a positive vote. So this is the case for the hypothesis that says that people vote positively for the targets that come from their own area, right? And what you see is that this is the graph for Spanish, this is the graph for German, English, and French, and you see Spanish are the most positive and Germans are a bit more reserved, but either way, the effects are the same across different languages of Wikipedia. All right, so this is the second example, which is about what similarity does to giving a positive vote. So now the question is, how about both quantities together? And the way I do this here is the following, right? So what I'm showing you now is status difference versus, again, probability of positive evaluation. This means that a low status person is evaluating a high status person. That's the other way around, right? A high status person is evaluating a low status person. And I'm showing you this bucketed in based on the similarity, right? So this is the curve that says when low similarity people evaluate each other, and the blue one is when high similarity people are evaluating each other, right? And what this really means is that when a high similarity person evaluates you, they don't really worry about the status difference, regardless of whether they have low status, or whether they have high status. The probability of giving a positive evaluation is about flat, right? While the people that are of low similarity, basically people that don't know each other, they pretty much behave according to the status difference in a sense, right? So what this seems to suggest is that status is a proxy for quality when evaluator doesn't know the target, right? And again, in academic setting, this would mean when you are evaluating somebody from your own area, you know their work, but if somebody asks you, what do you think about this other person, many times people resort to counting the number of papers or number of publications and trying to judge out of that, right? And this kind of process is supported by this plot. Okay, so this is what I showed you now is what's the effect of status, what's the effect of similarity, and how are the two working together. As there was asked before, there is definitely a selection effect of actually who shows up to cast a vote at the election. And what I'm showing here is basically the relation between status difference and similarity. And what this says is that when the status difference is high, similarity is also high, which means that for that elite evaluators, right, basically high status evaluators show up for targets that come from their own area of expertise, right? That's how to read this plot. Okay, so let me now show you another interesting question, which is sort of a puzzle, right? So here's a question, right? What we know so far, what do we think would happen with, how does the probability of giving a positive vote behave as a function of the status difference, right? And based on what I showed you so far, our hypothesis would be that the plot is monotonically decreasing, meaning that probability of plus decays with the status difference, right? So this is when a high status person evaluates a low status person. This is the other way around, and this is when people of similar status evaluate each other. And the way we can arrive to this is because those flat lines were like decreasing with the status difference, the first plot I showed you, right? Actually, if you look at the data, this is how the data looks like, right? So this is the status difference. This is the fraction of positive votes or probability of receiving a positive vote. And what you see is this kind of general trend that is as we'd expect, but you see this dip here at 0, right? And then you see a dip and then a rebound, right? And the way you could think about this is the following, is basically that people are the most harsh to the targets that are of the same status, right? Which in some sense you could think about this, that it's the competition hypothesis, right? People are the most negative towards their peers. And the way you could think about this is you could call this a mercy bounce, right? That when a high status evaluator evaluates a low status person, they're like, there is some hope, let's be positive. Here's your evaluation, right? So that would be one possible story you could make, and the question is, is this really going on, or how could I explain this dip at 0, a dip at status difference 0? And the way, so what do we know? You know, the question is, why do low evaluations come from users with the same status? Or why does it appear so to be in the data? So the first thing is that this hypothesis of people being harsh on their peers is wrong, right? Because we know that the probability of a positive, giving a positive edge increases with the similarity. So that hypothesis is wrong. And really, the way you can explain this dip at 0 is that it's through this selection effect, right? Is that when high status people show up, they are similar to you. So what you are really doing is you are averaging these three curves, right, from my plot about status difference versus probability of a positive evaluation for different levels of similarity, right? So for low levels of low values of status difference, you have lots of people that are not similar to you. So you are really averaging in lots of red curve. But for when the high status people show up, those are similar to you. So you're averaging in lots of blue curve, right? So sort of you behave like a red curve, but then you add in a blue curve on this side. So and that creates you the bump, right? So this is really how you can explain that funny, interesting effect of evaluations being most negative at 0 status difference, right? So really, this is due to the fact that high status evaluators tend to be more favorably disposed to the target. Okay, so this is you know, how you can go into the data and try to analyze the effects and try to come up with a minimal set of features that tell you how people behave. So what I want to do now is actually start to say, okay, what can I do something useful with this, right? And here is one thing that we can start thinking about is, you know, how can I take these evaluations now and try to summarize them, right? And the reason why I would want to summarize them is, you know, maybe I want to determine some kind of rankings of users or items, or maybe I want to collect all these evaluations and summarize them because they result in a group decision, right? Whether this guy will at the end be promoted or not, right? So the question that I really want to ask is, you know, how can I aggregate user evaluations to obtain an aggregate opinion of the community, right? Or even later, I'll show you how can I guess community's opinion just from a small fraction of the makeup of the community, okay? And really, these questions, how I can make them concrete is that I can study this problem that I will call a ballot blind prediction, right? So what I want to do is I want to predict Wikipedia adminship election results without seeing the votes, okay? So here's the setting, right? What I will see is I will see identities of the first 5 people that voted, but I won't see how they voted, right? So I just see identities of the first 5 people that show up, and what I want to do is predict whether the candidate will at the end get promoted or not. And why is this hard? This is hard for 2 reasons, right? First is, obviously, I just see the voters, but I don't see the votes. And then the second thing is that I only get to see first 5 people, even though on average around 50 and more than 50 show up, right? So basically I get to see the first 5 people who walk into the election booth or whatever, and that's all I get to see. I want to say what will happen at the end. Okay, so that's the problem we are trying to solve, and you know, let's try to use whatever we have learned so far to try to do this ballot blind election prediction results for Wikipedia. Okay, so the way I will go about this is I will just show you a very simple model again that you can train by just counting, right? So what I want to do is I want to model the probability that user A, right, the evaluator, votes positively on the target user B. So the way I will write down this model is the following. I will say, you know, what's the probability of user A voting positively on user B? And the way I will decompose this probability is into 2 factors. So the first factor is just, you know, the baseline probability of A giving a positive vote. So this is just the empirical fraction of positive votes A has given up to this time, right? It's like how positive is this person overall. And then I will have this second term that will basically now tell me, okay, but how does A deviate when he's evaluating somebody with status difference delta and similarity S, okay? So really this will be now saying, okay, how does the personal behavior of A change when he's evaluating somebody with this kind of relationship to him? And when I say this kind of relationship, I really mean the status difference and similarity. And just to make the whole thing even simpler, the way I will do this is I will estimate this for all the users of the community and have a single value. And the other thing I will do is really, this will at the end be just 4 different values. I will break this space of status and similarity into 4 quadrants, and now I will, just for each of these quadrants, over all users, I will estimate what is their average deviation when they evaluate a candidate from a particular quadrant, right? So really, how many parameters does my model have? My model has 1 parameter for every person, which says how positive is that person, and then my model has 4 more parameters, right? So why 4? Because there are 4 quadrants, and for each of these 4 quadrants, I estimate how much does the person's probability deviate from their baseline on the average when they evaluate a person coming from a particular quadrant, right? And once I've done this, right, so I have n, where n is the number of users, plus 4 parameters in my model. Once I trained this thing, I can just estimate d by counting and averaging, and I estimate a again by counting. I will say I predict that our candidate got elected if this sum of the probabilities over all first k voters is greater than some threshold w. Okay, and that's my model. So now the question is, how well does this work, right? And here are the results, right? So basically what I want to do is, based on who showed up to vote, I want to predict the election outcome. So here is the number of voters that I see, and this is accuracy of this model that uses status and similarity to guess what you think of the candidate, right? And if I see first 5, I get accuracy of 71%. If I see first 10, I get 75%. For example, if I were guessing, my accuracy would be 52%, which means that 52% of the elections succeed and 48 fail. If I would be using, common sense features and just train a logistic regression classifier, I would do 67%. And if I would actually see the first k voters and their votes, then I could do 85%, right? Because many times it can happen that the first 5 people all vote in favor, but then the rest votes in opposition, so the guy won't be elected, right? And sort of I cannot pick this out by just seeing the first 5 votes, right? So basically the best I can do is 85. Guessing would give you 52. By just knowing the identities, it gives you around 70% accuracy, right? Which means that these effects of status and similarity seem to be quite strong when people are making these decisions. Okay, so that's sort of the first part of the things that I wanted to talk. Right, and what really the theme here is, how are you learning from the implicit feedback in a sense, right? That just the audience composition, right? Just the identities of people who show up already tells you something about the reaction, meaning tells you something about their opinion. Okay, so far we were talking about. Do you have a question? Yes.
So are you training those parameters in some separate training set, or?
I'm training the parameters up to the election time.
Up to the election.
Right, so I take the history. So the way I think we did it is we took, half of the history to train and half of the history to predict, right? So yeah, we are careful.
So how big is that training?
So we have 100,000 votes. We have I think we have around 20,000 people show up, and I think we have around, this is for Wikipedia, for English, and I think it's around 1,000 to 2,000 elections. Yeah.
I have a question. So why did you choose to select first k and not like randomly k from the all? So is there any reason for that? Does it change if you use a random sample of k of votes from the all?
That's a good question. Actually, we haven't really looked at it. The reason why we choose first 5 because we thought it's more interesting to know the outcome before the things happen and not sort of pretend that now later when you collected all the people, right? So this seems a more interesting problem. That's the only reason why we chose first 5. Okay, good, great. So moving on, right? So far I was telling you just about one person evaluating the other person. What I will start telling you now is actually that you can take these evaluations and put them together into a network, right? So you can think of these evaluations as a signed directed network, which means that where every edge between a person means that the source of the edge evaluated the target of the edge, and the sign tells whether that evaluation was positive or negative, right? And what is interesting is now that the network provides me the contexts for these signs, right? The network provides the context in which these new edges are created over time, right? And the question is, what can I say about user evaluations in terms of from the network evolution point of view, and the point of view of how does the network structure and the signs, how do they correlate, right? And here is one theory that you can build, and we will call this theory the status theory, right? So now, just one thing that you should note is that now in this theory, status is implicit, right? So for the rest of the talk, forget the number of edits as a status measure, but just think of status as some latent quantity that is unobserved, but edges tend to follow it. So what do I mean by that is that whenever A gives a positive edge to B, this is a statement that B has higher status than A, right? So if you think about the status difference thing that we were talking about before, now just the status theory makes an assumption that whenever A gives a positive edge to B, this is a statement that B has higher status than A. And similarly, whenever A gives a negative edge to B, this is a statement that B has lower status than A. And again, status now is implicit, latent, unobserved, and has nothing to do with previous definition of status, right? And the first thing to notice here is that positive and negative edges are in some sense equivalent and can be, and this kind of principle of status can be transitively applied over paths in the network, right? So in a sense that if A gives a negative edge to B, this has the same meaning if B would give a positive edge to A, right? And if I take all negative edges, flip their directions, and flip their signs, then I will have all positive network with the same status interpretation as the original one. So that's one way how to think about evaluations in the context of the network. The second way to think about the evaluations in the context of the network is going back to the structural balance theory, right? This is due to Haider in '46, right? And the way he started was with this kind of sentences, right? Statements: friend of a friend is my friend, enemy of my enemy is my friend, the enemy of my friend is also my enemy, or a friend of my enemy is also my enemy, right? And if you take these sentences and say, okay, what do they say about the network structure, what these sentences really are, they are statements about triples of connected people and how the signs should be assigned to the edges of these triples, right? So here are all possible ways how you can label a triangle, right? A set of 3 nodes being connected with positive and negative edges, right? And the first 2 ones you call balanced. Why you call them balanced is because they correspond to this intuition above, right? So the all positive triad says friend of a friend is my friend, and then the second one captures all the other 3 statements, right? You can say enemy of my enemy is my friend, or my friend's enemy is my enemy, or my enemy's friend is my enemy. Right? And these are the reason why you call them balanced is because they correspond to the stuff above, and they are sort of stable in the network. The other 2 possible ways to label triads with pluses and minuses is the following case. And these 2 we will call unbalanced because they don't correspond to this intuition above. And the way you can think about this is the following. So this says I have 2 friends that are enemies with each other, right? So this is in some sense an unstable configuration or hard to maintain configuration in a social network, right? This one is there is a set of 3 enemies. So imagine this is a situation in a student dorm or in an apartment where 3 people don't get along too well, right? This is also a very unstable structure in a sense that sooner or later 2 of them will form an alliance, transform that triad to something like this, and then try to get the third tenant out, right? So these are the other way how you can think about status and balance in networks. And what is interesting is that even though I define these 2 theories at local level, at the level of edges, they also make predictions what happens at the global level of the network, right? So the status interpretation or the status theory would say that if you take the all positive directed network, then that network should be approximately acyclic, right? What that really means is that you should be able to topologically sort the nodes of the network or assign them integer values in such a way that positive edges only point from nodes with small number to the nodes of the high number, right? So basically this is status hierarchy. Status theory says that there is some ordering on the nodes based on their status, and then the edges point from people of low status to people with high status, right? And what balance theory predicts at the global level, it predicts emergence of coalitions. Basically, what balance does, it tells you that if you take just the induced graph on negative edges, then this graph should be approximately bipartite. What do I mean by that is that you should be, like the balance, if the network is balanced, then you should be able to find you should be able to partition the nodes into two sets, such that there are only positive edges between the member of the set and only negative edges to the members of the other set, right? And this implies coalitions or factions, things like that, right? So now the question is, given what I told you about status and balance, can I see any evidence for one theory or the other in the data? And what turns out is actually there is in aggregate much more evidence for the status theory. So here's one particular example where people behave according to status and not according to balance, right? So what would this be? This says friend of a friend is my friend, right? So in balance theory would say put a positive edge here, right? Oh, sorry. This is enemy of my enemy is my friend. So balance theory would say put a plus. What status says, A has higher status than X has higher status than B, so A has highest status, B has lowest status, so there is a negative edge here. And what you find if you look at the data about these signed edge creations, you see minuses happening in this particular case. Similarly, you see when you have a network now that has friend of a friend is my friend, so balance would say put a plus here, status says put a minus here, right? Because B has low status, A has high status. Again, what we see is that people put minus when they find themselves in this kind of network configuration, right? However, what you find is that balance is more applicable to the reciprocated ties. What I mean by that is that if I give you a positive edge, then status theory would say that you return that with a negative edge, right? Because I said you are higher status than me, so the edge that comes in the opposite direction has a different sign. Balance theory would say, if I'm your friend, you are also my friend. And what we find is that the dyadic level, so at the level of an edge being reciprocated, we see much more evidence for balance. Why this is interesting is because it sort of gives you two ways how to think about positive and negative edges, right? One way to think about this is, I agree with you, I agree with your opinion, or the other one is I respect you, right? And status seems to be more about this than it is about whether you agree with someone or not, right? So this is at what you find at the level of global network structure and triads and so on. So again, even with the implicit notion of status, you see much more status evidence for the status theory much more. The other thing that you can start studying is thinking about the global network structure and how the edges relate to it. And the way, sort of the intuitive picture that we many have about social networks is that they look something like this. What do I mean by that is that we have these densely connected clusters and then a few edges, linking these clusters together. And the question is, how does this kind of structure and the edge signs interact, right? And one thing that I will define for the now is something that I will call embeddedness of an edge. And an embeddedness of an edge is simply the number of shared neighbors that A and B, so the edge endpoints have, right? So heavily embedded edges appear inside the clusters, right? Because there is lots of edges around them, and this would be an edge with low embeddedness because these two endpoints don't share any common neighbors, while this is a heavily embedded edge in some sense. So now what you can do is you ask, okay, how does the probability of an edge being positive change with the embeddedness of an edge? So this is the embeddedness of an edge. That's the probability of the edge being positive. You see that it increases and then levels off. This flat line is the network where you keep the network structure the same, but you randomly shuffle the positive and negative edges around. So really, the point is that then there is no dependence between the edge being positive and the edge and the embeddedness. So this line is flat. So what this tells you is that edges that are not embedded are more likely to be negative, and edges that are highly embedded are more likely to be positive. This is for the opinions network. This is for Wikipedia network. What is interesting here is that for Wikipedia network, the effect is even stronger. One important difference between opinions and Wikipedia network is that on Wikipedia, all the edges are publicly visible. So giving a negative edge is publicly visible, and it's of high cost. On opinions, nobody sees the negative edges, right? So even if I, as an opinions user, create 10,000 negative edges, nobody will know that I created them. So in some sense, there is no social cost to being negative towards others. Nobody will know, they don't even know they received an edge, nobody knows you created a negative edge, right? What is interesting is that this public display, further attenuates this effect. And now let me go towards the application of these things. So what I would like to do, again, the application will be a simple prediction task. And now my prediction task is the following. I'm given a network, I'm given a single edge, and I want to predict whether that edge will be positive or negative, right? So I want to predict what will user A think of user B, right? So in some sense, I'm not predicting is user A connected to user B, but I'm really trying to predict what does user A think of this other user B, right? And the way I will create my model is very simple. For a particular edge AB, I will just represent it with a set of 16 features, and these 16 features will just count in what kind of triads is this red edge embedded, right? There are 16 possible directed signed triads in which a particular edge can be embedded. 16 because for every edge here I have 2 directions and 2 signs, so that's 4 options. So I have 4 options here, 4 options there. So there are 16 possible ways a particular edge can be embedded in the network, right? So what I do is I take this red edge and I represent it with a vector of 16 numbers where each number corresponds to the count of how often does this edge appear in this kind of context, right? And then I just train logistic regression classifier, like very simple, right? And what is cool is that I get more than 90% accuracy, right? So basically by just knowing in what kind of network structure or network context a particular edge is embedded, that tells me a lot, that tells me pretty much everything about how this edge will be created, what will be the sign of this edge that is created in the future. And what is even interesting now is that I can take this and start asking, how well do these models generalize across different data sets, right? So what I can do is I can take my model and try to apply it to different data sets. And as I was telling you before, the data sets we are using are very different in a sense that for these opinions, who trusts whom network, the positive edge means I trust your product reviews, negative edge means I distrust your product reviews. As I said, here nobody sees your negative edges. So all people see are positive edges and negative edges are completely private to you. In some sense, no social cost to them, right? Then we were talking about Wikipedia, where people support or oppose somebody else being promoted to become an administrator. What is interesting here is that all the edges are publicly visible and publicly signed. So you know who created a particular edge to someone else. The other thing is this is also, in some sense, a very serious setting in a sense that people work for years to be promoted, and then somebody shows up and says, no, I'm against you, right? And then the last data set that I will mention, that sort of I haven't mentioned before, is also Slashdot technological blog social network. So Slashdot is a blog that has where people comment on technological stories, and together with that blog there is also a social network of friends and foes. And in this case, sort of, it's not clear what friending or assigning someone as a friend as a foe means. It's almost like teasing someone versus not teasing them, right? So all I want to say is these are very different data sets. So what I will do now is I will train my logistic regression on the row, right? So here I'll show you a table where I will train on the row and I will predict on the column. Okay, so these are my results, right? So the way to read this is the following. What I do is I train my, imagine that I want to predict how people trust each other. But I train my logistic regression on how people trust each other, and I predict on how people trust each other. And I'm doing cross-validation and holdout, so this is not overfitting or anything, right? So my accuracy is 93%. Now I take my Slashdot data set, which is friend and foe relationships. I train my model here, so I estimate my logistic regression coefficients here, but I want to predict how people trust each other, right? And I lose 1% in accuracy. Or I take the voting data set, and I want to predict trust, and again, I lose less than 1% in classification accuracy. You see, in other two data sets, the same kind of behavior, right? For Slashdot, of course, I do the best when I train on Slashdot, but whenever I train on either of the two other data sets, I don't lose too much. Similar is true for Wikipedia. What you also notice is that our error rates on Wikipedia are much larger, right? That predicting votes is harder than predicting trust, for example. But what is cool here is that the same model with the same logistic regression coefficients, if you like, does equally well and sort of really well across all these data sets, even though they are widely different. The meaning of the edges is very different. Communities are very different. Sometimes these edges are publicly visible. Sometimes they are completely private. The same thing predicts behavior well in all these different cases. So really, this generalization at least hints that these models seem to be very general and seem to capture the essence of how things are happening in real life, right? So this is really what I wanted to present or to tell you about today. And the sort of what we were looking at is, that in many situations, opinions or evaluations are expressed, but, the underlying principles driving them may not be obvious, right? And what we then we went and empirically studied what kind of ingredients go into this process. And I showed you two important things, or two biases in some sense. One is the importance of relative assessment in terms of status differences, and the importance of prior interaction in terms of user-user similarity. Right? What came out in the second part of the talk, right, was this question of what are the dimensions of the opinion and how, status and similarity, what kind of role they play, and, this confounding of, yes, I agree with your statement, or your statement is technically correct, right, in a sense, or I respect you versus I agree with you, right? And what is interesting to think about this, especially in online domains, is that basically people apply these multiple dimensions of evaluations, right, but interfaces, they collapse them to a single dimension, right? You can sort of only like or dislike an item and things like that, right? And then another interesting thing for future research, right, is really how do communities form collective judgments in these social applications, right? And how can I model outcomes of group decisions from a small set of evaluations, right? And my example here was predicting the election results, right? That I only see the makeup of the community, and I want to predict what will be the outcome of the community decision process. And actually, later this year, we worked more on this, where we were asking, how does the audience composition, what does it tell me about the quality of the online content? And here we were looking at Stack Overflow question answering sites, where you can, just based on who shows up to let's say, answer a question, or who views the question page, tells you a lot about, whether the page will have a long-lasting value, which means will people keep arriving to it even 1 year later the question was asked, or, do people find the question to be sufficiently answered, and so on. And all these kind of things you can do by just observing what is the makeup of the people that show up on the question page. So what would I like to say, right, is what is another thing that's interesting, and I haven't addressed it, right, is really about that evaluations create incentives, right, and then actually that sometimes unfair evaluations can produce better or more desirable outcomes, right, in a sense that we can now start thinking about what kind of status and reputation mechanisms maybe we should design or build into these online systems so that we get the effects we want, or that we get sort of the true evaluations, whatever those may be, right? And really, I think at the high level, what I was trying to show you is, how we can use online data to understand a range of forces that work in this kind of evaluation processes, and use this to inform the design of new computing applications. So with this, I'm done. Here are the papers. Here's the website, and I'll be very happy to take questions.
Okay, that's great. So we're now going to take some questions. We're going to start with a question from here in Berkeley, and then we're going to go to the group in Stanford. So if you guys can get ready down there. All right, we'll start with the question from Berkeley.
Or give her the mic.
There's a 15-second delay between here and Stanford. Okay. So just give me 5 seconds. Hey, Gary, are you there? Hey, Gary, are you there?
Yeah, can you hear us?
Yes, we can hear you. Okay. We're going to ask a question first, and then it's your turn.
Yes.
If you don't mind going back to the slide with the opinion and the Wikipedia graphs, like the two
interesting?
It was about the networks, so I guess it was.
Okay, well, ask me a question and I'll tell you.
That's a question. It seems to me there's a lot of evidence of strategic voting going on, that they might not necessarily be in the way that you may have predicted it, which is, it seems like who shows up in Wikipedia to vote, and how, and then in addition to that, the fact that their votes are public, it says to me something maybe about like your reputation as a voter is at line. And so do you find evidence, I mean, this seems to be very similar to how votes go down in Congress. And so you see lots of votes that pass with supermajorities. You see lots of people, lots of bills that fail with supermajorities. You don't see a lot of bills in the middle. And so do you see any evidence of that, the distribution of wins? Or do you see people who lose tend to have not at the margin?
Yeah. So what happens is that generally all elections get more negative over time. So regardless of whether the candidate will get elected or not, the elections get more negative over time. That's the first effect that's happening. Usually the elections that fail, the number of people that vote is smaller. So people sort of don't even bother expressing the opinion.
Do you think this might help explain why people who aren't yet administrators vote more positively than people who are administrators? And that be the case that they may want to have a reputation of supporting other people?
So we actually looked at this, and we were for example looking at this the diversity in this personal how would you say decision curves, in a sense of what is the state of the election right now, what's the probability you will vote positively in the next step, and you find like very different types of behavior. So there is very little signal of anything like this going on. So we came to this data with lots of interesting stories, what all we want to study, and we couldn't find much.
Interesting stories, what we want to study. And we couldn't find much. Interesting stories, what we want to study.
Hey Gary. Hey Gary, can you use the audio from the Polycom, please?
All right, we've got the Polycom up now.
All right, if you guys have a question, go ahead.
All right, if you guys have a question, go ahead.
Thank you. We have a question from the audience?
All right, if you guys have a question, go ahead.
Thank you. We have a question from the audience? No.
Good.
Okay, no questions from Stanford. We'll go to a question here.
Stanford has no questions right now.
Okay.
Good.
We'll just continue with on our side.
Okay, so I have a question sort of about comments you made at the very end. So suppose Wikipedia wants to change their voting system. So using the things you did so far would require that people are not going to change their behavior in how they're going to, in response to these changes in voting rules. But the other thing you would need to think about before you can think about designing a new voting system is what Wikipedia is actually trying to do. And so for some of these settings, the opinions or Wikipedia, what is actually their goal in having the elections? So what is the objective they're trying to maximize?
So for example, Wikipedia, Wikipedia aside, opinions has a very clear objective function. So the way opinions works is that you contribute product reviews, other people vote on your product review and whether they trust you or not. That determines the ranking of the reviews that get shown to other users who come to the site. And then what opinions does, it has a revenue sharing scheme. So as you get more positive votes or more trust votes, your reviews get ranked higher, more people see them, so you get more money from opinions. So that's how the site works, right? So so from my point, so from the user point of view, the idea is the better reviews I write, the more trust edges I receive, the higher ranked my reviews will be, so more people will see them, which means opinions will give me back more money. because I'm the user who's contributing the content. So that's, for example, the way Opinions does this. So what would Opinions want to do? Maybe the Opinions would want to say that they want to have as few votes as possible and be able to determine this true ranking or good ranking of the reviews as quickly as possible, right? That the right reviews get on the top as quickly as possible. Stack Overflow has a similar problem, right? People ask questions, other people contribute answers, other members of community vote on these things, and the thing that gets upvoted the most gets on the top. So you would want good things to be up there on the top, or that would be one thing to think about.
And presumably part of what they want to do is change who's actually going to vote.
Of course, then you can start asking, for example, are high status people better at giving the final judgments, right? So are the votes of high status people more correlated with the final outcomes? So that would be one way how you could say, I don't need to ask this many people more, I can ask much fewer and get the same outcome as if I would get if I go to ask everyone. So those would be kinds of things to think about. But I definitely agree that really all these questions at the end depend on what is the community or maintainer or owner of the website, what is their objective, what do they really want to do. Good, yeah.
But probably such prediction, to move answers to the top as soon as possible, or reviews to the top as soon as possible, could introduce some sort of filtering bubble, in the sense that they are saying now for the Google that all these results on the top, nobody will go ever and read those at the bottom because they will already find something. And even if there is a good answer at the bottom, because your mechanism predicted some other to be on the top before, it would never get votes. So do you plan maybe to research something like this? Is the order of those also influencing the votes itself?
Sure, that's a good point. Is that especially the way sort of you get these rich get richer effects when sort of and the same happens in some sense in web search, where people go top down. When you have images, they talk about this golden triangle that you start reading here and then you skip the diagonal and then you look for the bottom part of the triangle also, because then you click the next button. So, there are papers and there are methods how to estimate these click-through probabilities, and then you can bias your ranking to put the stuff there where actually people look. So in this, I think you are opening a sort of a philosophical topic of, what are all these recommender systems doing, right? Like recommendations on Amazon, what is Pandora doing to our music tastes? Are our music tastes getting narrower or are they getting wider and things like that, right? So those are good questions.
Okay, I'll ask a question. So I was very struck by the one slide that you presented that had the Wikipedia versus and using these other networks and predicting Wikipedia and vice versa. And
sure.
I guess I was just wondering, sort of a little bit more about why this is. Is it because maybe the Wikipedia votes actually are a little more important, and therefore people are sort of not defaulting to some basic sort of social interaction, and they're trying to evaluate more objectively, or is something else going on here?
You mean just the more negativity?
Yeah, well, what you see is that, because you use the Wikipedia results to predict the others, and you get sort of poor outcomes, right? It's suggesting that people are behaving differently in those triads in the Wikipedia than they are in these other ones, right?
Yes. So the way I would understand this is that how to say that Wikipedia is just simply harder to predict, because even if I train on Wikipedia and predict on Wikipedia, I only get this. And then if I train my model on Wikipedia and want to predict /dot, Wikipedia model predicts /dot better than it predicts Wikipedia, right? So really, it just, the way I would say is that things here are less predictable. Maybe I wouldn't call them noisy, but using the set of features that we have here, I obviously cannot do is 0.8 that I can do. Here, the same model does actually 0.92, right? On a different data set. So I can train my model on a hard data set and predict an easy data set, and it's still fine. So what I would say is that just showing that the way that the network structure carries lots and lots of signal about human behavior, and in Wikipedia there are also other factors that you could consider, and hopefully you can increase this number.
This is another version of the same question. So this prediction task is conditional on having an edge,
yes.
Right? So is it like since Wikipedia's votes in elections, is the cut point different versus /dot or e-opinions? It's like, given that we have an edge, is the base rate for /dot of having, say, a positive edge 0.9, and in Wikipedia, you know, many of the votes are 0.5 or 0.6. That's just going to, one of those is going to be inherently easier to predict.
Good point. So your question is really, what's the baseline probability of giving a positive and what's giving a negative edge? So the point is, it's around 0.8 in all these data sets.
In all of the data sets.
For this experiment, what I did is I'm not training on a 80-20, but I'm subsampling the 80 to be 50-50. Right? So random guessing would give you 50%. So these are classification accuracies. If I go and train on the raw data, meaning 80-20, then these numbers all increase, you know, to 89, to 98 and things like that, right? So what I did here is I subsampled the positive edges such that I get the equal number of positive and negative training examples. So the baseline is 50. I mean, we did many more experiments. This is just the simplest one. So it's not that effect. That's all I would like to say.
Okay, great. Well, let's thank our speaker one more time.
Okay, thank you.